So, well, what I was thinking that we can do is I'm gonna try to go through the steps in creating a solution for the front end with regards to keeping your credentials safe or as safe as possible. We're going to have to talk about the as possible aspect a lot, I think. Uh, so uh, I'm going to go through the steps and I'm going to try to remember to stop often, and then if you have any questions, we can talk about whatever questions you have. Uh, so uh, well, anyway, the topic, as I said, is how to work with credentials in the front end and do it in a way that is safe and secure. Uh, so the goal is that when when you have your credentials in the front end, you prevent them from being stolen or compromised. So that's the ultimate goal. This is an issue because the web browser is an insecure platform. So there's a lot of different ways where malicious agents can access information that you have in your front end. Uh, so uh, we are not going to discuss the back end today, I think, uh, but basically the way the front end ends up having a token or some form of credentials is by interacting with the backend. It authenticates and it receives a token. It doesn't matter if the token is a JWT or just a random sequence of characters. For the purposes of this topic and this discussion, it doesn't really matter because from the front end side, the token is a black box. It's just a string that the front end needs to send to authenticate requests, right? So the front end now receives a token from the back end, and there are three places where the token can be stored. The token can be stored in a cookie. It can be stored in local storage. A derivative of local storage is this other thing called session storage, which I considered it the same thing. Session storage is not very useful, to be honest. And uses the same API as local storage. So we're gonna consider those one thing. Uh, so we have a cookie. We have the local storage, and you can also keep it in memory, right? So you have your front end application, which might be React or anything else, and when you receive the token, you can put it in a global variable and keep it there, right? That's another option, right? So those are the three options. Any questions about that, or can you think of any other way to store your token that we need to discuss?
So it was memory or cookie, and cookie can be local or session.
Uh, the cookie is a cookie. We're going to talk about different types of options for the cookies, but you have a cookie, and then you have local storage and memory, and there's this other thing I mentioned. This other thing called session storage, which is similar to local storage, uh, but the session storage doesn't really provide much benefits over putting the token in memory. Uh, so I don't think it's very useful. But we can talk about the differences if you want between session and local storage when we get to the details. That's a valid thing to talk about because there are some differences, and in some cases it might make sense to use session storage instead of local storage. But anyway, those are the options. We can call it four options then: memory, session storage, local storage, and cookie. So those are the options that you have. Now, looking at this from from the other side, we can talk about the risks, right? And there are, as we discussed many times in this channel, there are two main attack vectors that you can be a victim of with your application, right? And these are XSS, which is short for cross-scripting something. I forgot what XSS means. Hold on. Cross-site. I missed one S. Cross-site scripting. That's XSS. And then the other one is CSRF. Some people call it CSRF, right? Which is cross-site request forgery, if I remember correctly. And they're very different, and both are very common attacks that you may be a victim of if you don't think things carefully when you design your front end or back end.
Are both of those the same in regards to somebody needs to steal your credentials or your token in order to perform those?
They're actually very different. So they have very different ways of operating. We could talk about that. So XSS, cross-site scripting, is an attack that happens on your own application. So this is when the attacker infiltrates some JavaScript code to run inside the context of your own front end. So that's XSS. CSRF or CSRF is completely different. CSRF is where you have an attacker that has their own website, and they attack you by sending a request, a background request. So typically this is an AJAX type of request or a form post directly, cross-origin over to your backend. So this one is basically you have an attacker's website that is designed in a way to be malicious and confuse the user of that website, the attacker's website, and without the user knowing, the attacker is able to send an authenticated request to your backend. So those are the two attack vectors, the most popular ones, and so from these two, CSRF has some ways of prevention that are well known. XSS also has some ways of prevention, but it's more of you have to be careful in how do you design your application. It's basically the measures that are designed to prevent foreign JavaScript from ever be able to run within the context of your page or your front end. So one thing that a lot of people talk about with regards to XSS, cross-site scripting, we discussed this in the channel many times. People seem to recommend that you shouldn't use local storage to store your credentials, and the reason is that if you get some foreign JavaScript running in the context of your page, then that JavaScript has full access to local storage, right? So what we're saying here, and this is what I find troubling with that, basically the people who advocate for never use local storage, they're saying that you're vulnerable to XSS attacks. There's nothing you can do about that. And since you're vulnerable, then you shouldn't use local storage. And I prefer to talk about how to prevent XSS attacks more than what to do, if you are already a victim, which less people talk about, right? So if we talk about prevention of these two attack vectors, first and foremost, the main thing you should always use encrypted, right? Encrypted communications, right? So HTTPS always, right? That applies across the board, and that is at this point it's a no-brainer. You should always use HTTPS for your production site, right? Any doubts about that? Do you have any questions about that?
Yes.
Yeah, go ahead.
So to ensure that you enforce HTTPS to all your services, you would want to make sure that you have something like Nginx set up in front of all your services as a rule to only accept HTTPS connections. That's what that would actually kind of look like in practice, correct?
Yes, right. So this is how I like to do it. Some people like to do it in the Python side, but yeah, I don't want to complicate things on the areas where I work, right? So I want the application to be as simple as possible. I don't want to complicate it with encryption, and besides, doing the encryption in Python is not a good idea because Python tends to be slow. So Nginx can do it much more efficiently. And as you say, once you have it in Nginx and everything, the whole traffic goes through Nginx, there's no way that you can make a mistake, right? So yes, you make Nginx receive traffic on HTTPS. Something that's very common is to also put a rule in Nginx that if it receives traffic on port 80, unencrypted, that it redirects to 443 on the encrypted connection, which is fine. But there's one thing that you need to keep in mind. So imagine if the client sends the first request on HTTP, not encrypted, and it sends cookies with it. Regardless of Nginx then redirecting, the cookies are traveling, unencrypted, right? So that's a problem. You don't want your cookies, especially the sensitive cookies, to be ever on an unencrypted channel. And there's an option for cookies for that, which is called secure, right? That's one of the flags that you can set in the cookie. I believe, if I remember correctly, that is not set, right? Yeah, it cannot be set by Flask, right? Because we also use Flask in development without encryption. So normally you will want to set that for production. And when a cookie has the secure flag, then the browser will never send it if the client is using HTTP, right? So go ahead.
Sorry, can I make a quick question there?
Yes.
I'm Lurker, by the way. Hi, everyone. So you say the first time the cookie is sent on port 80, it's unsecured, right? So it's up to Nginx to get back the response on 443, right?
That, yeah. It's not really that. So the problem with sending cookies in a connection that is not encrypted is not on the back end. The problem is that the cookie goes from the client's machine over to your backend, and it might stop at different places on the way, and all those places will have access to that cookie because the connection is not encrypted, right?
But so, the question is, the first request ever made, it's from the client to the server, right?
Yes.
But it's the cookie you get, it's from the server.
Okay, I see what you mean. So this will be a cookie that was set in a previous session, which was maybe it was an encrypted. Let's say you connect on HTTPS and you get a let's say if you're doing a traditional thing with Flask login, you get a session, right? And then you have in the client machine there's a cookie, and if that cookie doesn't have the secure flag set, the next time if the same machine connects on an unencrypted channel on HTTP, the browser will send a cookie. It will not know any better, and it will send it, and it will go unencrypted, and anybody will be able to get it.
Right. Right.
Does that make sense? So,
There's no way to make sure that the client first uses an unencrypted connection. I respond with an encrypted connection, and there's no way for me, the server, to make sure he keeps sending stuff in that encrypted connection. He refuses to send any more data through HTTP.
you can disable port 80 if you want,
Well, okay.
right? I mean, you can go, that will be the ultimate solution, right? Not offer a port 80, but traditionally people leave it there and do the redirect, which is fine as long as you keep in mind the cookie issue, right? You need to make sure that your security or sensitive cookies are all set to be secure, so that they're not ever sent on an encrypted channel. So we discussed the 4 storage options, and we discussed the 2 attack vectors. So with XSS, we already said that if you put you received a token, right, in the front end. If you put it in local storage and you happen to be a victim of an XSS attack, then the token is easily accessible to the attacker, right? Another thing that not many people say is that if you're a victim of an XSS attack, the attacker will not need to steal the token, right? The attacker is running JavaScript code in your application, right? So they can do whatever you can do in your front end, right? So stealing the token is probably not a concern at that point, and you're really toast on many other ways, right? So as I was saying before, you should concentrate on making sure as sure as possible that you're not vulnerable.
I think sorry, go ahead.
No.
Okay.
Your turn.
I think that point that you just made is frequently ignored. A lot of articles that I've just read from guys online, that if someone does actually compromise you through an XSS attack, they can just act as a normal user and do anything that you can do and change privileges and so on.
Right.
So, like you say, having a layered approach to make sure that these tokens only last so long, can only do so much if they are a certain, like time old, if they're fresh or not tokens. Correct, like a freshness pattern for your tokens. Is that a common strategy?
Well, right. So this is what we're going to talk about, the layered approach, right? So what I'm going to suggest is that sometimes you really have to use local storage, right? It's too useful to basically to give up, right? So then you look at different ways to prevent or minimize the damage should you become a victim, right? First of all, let me complete this. So XSS, we said that local storage might be a problem, right? So if you look at CSRF, or better said, so if local storage is a problem, you may think, as we discussed in the channel, you may think that cookies might be better, right? So you say, okay, I'm going to use cookies for this, right? Great. So now let's look at CSRF. So CSRF, the other attack vector, it's actually very easy to be a victim of if you use cookies, right? Because so you have a website, some other website that sends a request to your backend, and the browser, if it doesn't know any better, it will send any cookies for your backend along with that request, right? So if you only rely on a cookie for authentication, then an attacker might be able to send a request to you, and it will be authenticated from whatever token you sent in a previous session, with the user, right? So that's also a problem. So basically, for XSS, you cannot use local storage, and for CSRF, you cannot use cookies, right? So now the remaining out of the 3 possible storage options. I'm going to consider session storage same as local storage here. So we have memory, right? So you can put the token in memory, and that's fine, right? It's harder for an attacker. So if you get attacked with an XSS attack, it might be harder for the attacker to find where you have the token. You know, say you have it in a
the
React
memory dump or something like that. What can he do? Make a memory
right?
dump
Yeah,
or
I mean
something,
it might be possible, right? If so let's say you have it in a state variable, in a React state variable. There might be a way to navigate the React structures, you know, and find it. It's very unlikely, in my opinion. So it's more secure, definitely. If you can keep the token in memory, that's the best, right? I don't disagree with people who say that. The problem
Then
with,
I guess
go ahead.
even maybe just do a search for the pattern of a JWT token, but they do vary in length, correct?
Yes, but they're unencrypted, right? You can decode a token, so you can find it. Yeah, it's true, and they all start with EY blah blah blah, right? So you could search the memory. So definitely.
The cost to the user experience, which at the end of the day is probably the most important thing.
Right.
One of the more important things to me, at least, is you're just going to make people hate your app if they have to log in all the time.
So that's what I was going at. So let's say we all agree that memory is by far the most secure, right? So if you keep your token in memory, when the user refreshes the page, the token goes away, right? And it needs to log in again, right? There's nothing that can preserve the user session, right? If you keep the token in memory. There's no way, right? Both local storage and, local storage and session storage, both, plus the cookies, all allow the session to survive a page refresh, but not memory, right? So memory has that big drawback that makes it not viable, in my opinion.
So it's the lesser of two evils here. So
you have to compromise, right? You do have to compromise, right? And you have to accept a little bit of risk to create a user experience that that basically your users will not hate, right?
Yeah. And to prevent XSS attacks, people often say that we have to protect our platforms from foreign JavaScript. Mm-hmm. Do we count the third-party libraries that are in our projects as domestic JavaScript, or is that
right? Good question.
Assumed fully audited code? Because I'm definitely not experienced enough to audit every third-party library that I use. I check through. I do the best I can.
Yeah.
But,
right. So this is definitely a problem. So if we're talking about preventing foreign JavaScript from ever running into your app, so you have two possible ways in which external code can infiltrate. So the two ways are through strings that you show, like someone. The typical example will be someone in a comment for something on your application, typing a script tag with some JavaScript code, and then you show that in a wrong way, and that instead of showing the actual code, basically it actually executes the script tag. So that would be the most the traditional way in which XSS attacks occur, right? This is not so easy these days, to happen. It's less frequent than you might believe, and this is because most web frameworks don't do this by default anymore, right? So if you put a script tag in a string and then you try to show that string in a React app or in a Jinja template, both escape by default, right? So it's not gonna run, right? You really have to go out of your way to make that code actually run as code, right? So this isn't that likely to happen. The other way is if you import a bunch of JavaScript libraries in your web page, then you can assume. I'm not really sure, if I think this is likely, but I guess it's possible that when you import from CDNs, for example, a CDN might be compromised, and maybe an attacker is able to stick a little bit of extra JavaScript into all the libraries that are in the CDN, right? So then if you download jQuery or whatever else, it might be a compromised version of the library that you want, right? Which includes the library, so it has all the code that you expect, so your application will continue to work, but there's going to be an extra thing in there that maybe can scan local storage for tokens, and steal anything uploaded to some site, right? So that's, I think, from the two potential ways in which you can get bad JavaScript into your application, that's now is the more likely one. And when you work with React, this isn't really that common, or at least it shouldn't be. You should incorporate all those libraries into your project. That's preferable instead of importing them from CDNs. So if you, for example, I'm going to give you an example. Let's say you use Bootstrap, right, in your application. So instead of putting the Bootstrap script tag in your index HTML page, it's better to include Bootstrap into your project. So you do npm install Bootstrap. So install the project from npm, and now you have a version that's local in your developer environment. And then when you build React, the source of Bootstrap gets included into your application, and it's part of the bundle, the JavaScript bundle that includes your code. So that now basically you are shipping Bootstrap or any other libraries. So basically there's only one source, right? So if you can do this with every library, then all the JavaScript for your application comes from your backend, which is better.
Do you think the cost of serving the whole React stack or the whole Bootstrap from my server is worth it?
Definitely going to be more traffic for your server. From the user's point of view, so a few years ago, people were all good on the idea of using CDNs. They said that it will save download time for users because, right, if many websites used jQuery, for example, the user will have it cached on their browser, right? So then when they get it from one site, they can reuse it on another site. But these days, for security purposes, that none of that happens, right? A browser will download it again anyway, right? So there's really not much of a benefit. And for security purposes, again, it's considered safer for you to deliver all your JavaScript, even the third-party dependencies. So I would recommend that you do that. So basically,
now we're hoping npm doesn't get attacked, right?
Well, so hold on, not really, right? It's not really like that, because the only time you are at risk when you say npm install Bootstrap, right? You may get let's say at that point, npm is compromised. You may get a bad Bootstrap, right? But then your project is going to be pinned to that version of Bootstrap that you installed back then, right? And it's not so easy to, I wouldn't say impossible, but I think it's unlikely that a version that is known good will become bad later on, right? Because they have hashes, there are protections against all those things, right? So if today let's assume today npm is not compromised, you can install those libraries, and even if you install the same version of those libraries in the future, more than likely you'll be okay. So the risk will be when if you decide at some point to upgrade a library in your dependencies, then you might have a little bit of a risk window when you get the new version once again. But that's it, right? So okay. So let's say you got your you got all your JavaScript libraries from your own application. You're shipping everything yourself. So now really there's no need for you to accept JavaScript from any other sources, right? So there's a thing that you can do to tell the browser that you, under no circumstance, you will accept downloading JavaScript from a different origin beyond your own. And this is called a CSP, a Content Security Policy. I don't know if you've heard about that. This is a meta tag that you add in your HTML page, the index.html, where you declare, there's many things that you can declare there, but one of them is what are the allowed domains or origins from where you can you have JavaScript, right? So you can tell it only my own, and then if an attacker somehow manages to include a script tag into your application on through any means, it doesn't matter how. If it tries to download JavaScript, malicious JavaScript from some place, the browser will say no, assuming that the browser is modern and it implements the CSP rules, right? So you should
question.
do that. Yes.
Yep.
Go ahead.
No, I wanted to ask. Yeah, thanks. I wanted to ask. So, but this also means that you then can't use any analytics like Amplitude or any other application that you're using in order to get your data, or would that also be in your security policy?
Right. You will make exceptions for all the things that you need. Yes. Yeah. So basically, you start by saying by closing everything, and then you open, for the one or two things that you need. There's also a way to go ahead.
But then that still means that you're at risk then through if the amplitude gets hacked, right? Or if segment gets hacked somehow,
Yes.
and I have an exception for segment's code, then that leaves me with the same risk. I can't ship segment on my own, right?
Probably not. I'm not familiar with the segment library particularly, but if you cannot install it, it will be the same with Google Analytics actually. So yes, you will need to make exceptions for that. Yes, yeah. So you're gonna have to trust that those are well kept and maintained, which I think they are.
Does this work for, let's say, the attacker gets to inject the JavaScript itself, not download from another site, right? So what the meta tag is protecting is the very same page I'm right now on.
Yes,
right?
Correct. Which if
every single script tag inside that HTML.
Correct. So in that page. So if this is a React application, that protects the whole application, right? Because you never change your page, right? It's a single page,
okay,
right? If you have an application that changes pages, then you have to put it in every page, right? So if this was a Flask, traditional application, it will be in your base template, right? So that you have it on every page, right?
Good.
Can I ask?
I thought you were about to talk about CORS. I don't know how you.
Yes,
pronounce.
we can talk about that too. Absolutely.
I thought you were leading to that.
It's right. There are so many things. Any more questions?
I probably after later, but I was curious. When I launched my own application, you told me that I needed to urgently change and check that my application's secret key was different. Is that another attack vector that's different than the two that you've already described, right? That somebody understands the secret key for my Flask application Is that only a concern for Flask, or does that also exist in a React application? I'd love to know how that works.
Okay, so the secret key is I wouldn't say it is a concern for React applications, unless you use the session, the Flask user session for anything. So it is a concern for the session. The session is stored in a cookie, and the cookie is signed with the secret key. So if the secret key is compromised, that means that the person who knows the secret key can create sessions that your backend will accept, right? So they can make sessions that say anything, right? They can say their user number 1, which is you, right? For example, right?
And then they don't need to know any authentication, right? If they know the secret key, then it doesn't matter
because,
what kind of...
Right, because in a Flask application, that's the authentication. The authentication is having a session with the user ID, right? So if they can fabricate sessions with whatever contents they want, they can put I'm user 1, right? And then they can log in as you, right?
They can mimic an authenticated user of any kind with that. Knowing the secret key, they can mimic an authenticated user.
I don't understand the question. I'm sorry.
So having I'm confirming if I understand correctly. So if some attacker were to get the secret key, they could mimic and they have to have the secret key.
If they have the secret key, then the security of your application is lost, right? It's really bad. So it's really bad. You should make sure that the secret key is not known. So if you suspect that your secret key was compromised, then the thing that you need to do is change the secret key. You pick a new one, right? So use a new one, and then the moment, and this is what happened in this particular instance you were asking me, when I suggested you change your key, then any active sessions that are out there will stop working, right? And that's what you want, because some of those might be malicious, right? So the good ones will stop working too. Everybody will have to log in again, right? Which I think it's a small price to pay for security. Yeah. So let's see. I have a list here of all the things. What did I? CORS. We didn't talk about CORS, right? So there's a huge confusion with CORS. So normally, modern web browsers do not allow site A to send a request to site B, right? That's not allowed. There's a thing called the same origin policy that browsers implement, and that's the default, right? So remember back at the beginning we were talking about CSRF, and CSRF implies that there's an attacker with a website sending a background request to or a form post to your backend. So normally that would not work, right? In modern browsers, that's not allowed unless you allow it. So a lot of people think that CORS is a protection mechanism, and it's the reverse of that. CORS is what disables the protection mechanism that the browser uses by default. So an additional layer, we're talking about all these layers, an additional layer of protection that you can use is to not use CORS. So basically do nothing in this case. So don't have CORS on your application if your application works that way, right? If you have your front end and your back end all in the same served by the same origin, by the same web server, then you don't need CORS. So don't use CORS. Don't have anything related to CORS, and then that will tell the browser to use the most secure settings, right? And then CORS allows you to, in the same way as the CSP, the Content Security Policy, with CORS, you can enable certain things but keep other things protected. So if you have, for example, if you have two domains, right? So if you have your front end comes from the www.whatever.com, and then you have an API.whatever.com for your backend, then you can configure the API server to only accept requests from www, but not from anything else, right? So you have to play with those settings. So if you can, then don't use CORS at all. That's the best. If you do need to open your backend to accept cross-origin requests, then make sure that you only allow the origins that you own, and then keep everything else closed. There's one more thing related. So we said that, so let's say you have to use CORS, so you do have some risk by allowing other origins to send requests to your API. Another thing that you have is another flag in the cookie. So the session cookie, or if you store a token in a cookie, another thing you can do is you can set the same site flag. Same site is another thing that you can say, and when the browser sees a same site flag in the cookie, it would only send it when it sends it from the same origin. But it will allow cross-origin requests, but in that case it will not send the cookie. And this is another way to prevent CSRF. So all these things, you should consider. In my view, so some people you will find that they say, okay, so use the same origin for everything, and then set the same site flag on your cookies, and then that's a perfect solution, because you're using cookies. XSS is not a problem. Nobody can steal your token because it's in an. I didn't mention this. The cookie should be HTTP only as well, right? So that JavaScript cannot see it. So the cookie is HTTP only, secure, and same site. So you set those three things in the cookie, and then that cookie is invincible, and that's the perfect solution. And I can partially agree with that, but you have to consider that not all browsers might implement all these things. Some of these, the same site flag is fairly new, so there might be a portion of your users that might not be protected by these things. There might be at some point now or in the future, there might be attacks on the browsers themselves that may disable cross-origin, same origin policy, that might disable the same site flag. You never know, and that's the reason why I recommend that you do these and every other thing, right? So that you have security on many fronts. All these things are so the browser security model originally was really bad. It was terrible. So all these things are patches that were added over the years to improve the security of the browser. If your client is not a browser, then none of this applies. CORS, all those things, they have nothing to do with your client if your client is not a browser, right? The client can do it whatever it wants. I'm sorry, I mentioned this in passing, and I forgot to put it on my list, but it is important. So we mentioned two flags on the cookies, right? The secure flag, which is important, and the same site flag that you may be able to use if you use same origin for your front and back ends. So the third one that you normally use to secure your cookies, it's called HTTP only, and this means that the value of the cookie is not accessible from JavaScript in the browser. So the browser has the cookie, it knows the value, but it doesn't expose the cookie to JavaScript. So if you get compromised with XSS, the malicious JavaScript will not be able to read the value of the cookie, which might be a token or a credential. So by making it HTTP only, you take it away from access from JavaScript. So normally you use those three. So it's HTTP only, secure, and same site. So you want all three to be present. When everything goes through Nginx in production and through the React proxy in development, then you are effectively using one origin for everything, right? So that is the ideal solution. That's good. It's good to do it that way if you can. And then in that case, a lot of the possible attacks are easily addressed. So you can create a content security policy that prevents any JavaScript from anywhere else. You don't have to use CORS, which is the best. So ignore CORS completely. So nothing about CORS. The same site flag on the cookie works, right? So if you were using cross-origin, you will not be able to use that flag. So in this case, you can. So yes, that is the ideal setup, in my opinion. So one way, so we discussed that storing credentials in memory is not a good user experience, right? Because a refresh wipes everything, right? So we're going to use local storage, right? So if you put your token in local storage, you can take all the precautions in the world to prevent XSS, but you can say, well, maybe I made a mistake. There's a small, maybe tiny chance that I missed something. So what can I do to minimize the risk if that were true, right? So one thing that you can do in that case is to use tokens that expire in a short amount of time, right? So you're not going to have a server that gives out tokens that last a day or a week. You are going to give out a token that lasts 10 minutes, let's say, right? So if you put a 10-minute token in local storage and it gets compromised after a couple minutes, then there's only 8 minutes in which it can be used to inflict damage, and then it's gone, right? So that's a good strategy. Another layered approach. If you store tokens in local storage, make sure they're not too long. Make sure they expire. The problem is that if the token expires too soon, it might expire before the user is done with your session, right? The user might still be using the application when the token expires. So you need to have a strategy to generate new tokens. And this was a question that I don't remember who asked in the channel, right? If you are protecting your access token, right? We're going to call the main token, we're going to call it the access token, and then there's going to be a refresh token. So if you do all these, you go through all these crazy measures to protect the access token, make it short, and then you also have to store a refresh token that you need to use when the access token expires. Then what's the point, right? Because now we have a refresh token that is long-lived, that maybe last 24 hours or a week, or however long you need, and we're back at the beginning, right? Now the attacker can get the refresh token, right? So we're not doing that, right? That's not a good approach, right? So you need to find a different way for the refresh flow to work, right? You're not going to do the same thing that you do with the access token. So one approach that I like, it's not the only one. So the approach that I like is when the user authenticates, the server provides both an access and a refresh token. It provides the access token as a response, right? So that the client can get it and store it in, say, local storage. And it provides the refresh token in a cookie. Okay, so a cookie that is HTTP only, secure, and if possible, same site. 3 things, right? 2 or 3, right? So you provide those 2, but they go through different ways, right? So the client cannot see the refresh token because it's HTTP only. It's in a cookie. So the only thing that it can do is when the client sends a request for the refresh token, the browser will send that cookie with the refresh token. Okay, so the client authenticates by sending the username and password that the user typed in a login form, and then the server responds with a body. The response body includes the access token, and it also sends a cookie with the refresh token, right? So the client doesn't even need to know that it's getting a cookie, right? The client will not see it. It's a HTTP only cookie, right? But the browser will store the cookie. Cookies also have they have many more options and flags beyond the 3 that we discussed. One of them is the path. So you can specify that the cookie is only sent when the path of the request URL is certain thing. So you can even restrict this refresh token cookie to only be sent when the client makes a request to the refresh token path, right? So if you have a /tokens/refresh, you can say that cookie only works for that URL, okay? So you make it even more secure because it's not going to be sent on any other endpoint. Okay. So now the client goes about its business. It sends requests by passing the access token, and then eventually, 10, 15 minutes later, that token is not going to work. So the client will send a request, and it's going to come back with a 401, right? So at that point, what the client can do is send a request to the token refresh endpoint, and the cookie with the refresh token will go on its own, so the client doesn't need to do anything. But the problem that so far this isn't secure, right? We discussed this in the channel many times. If you use cookies for any kind of authentication, then you are vulnerable to CSRF. You have to use an anti-CSRF token to make sure that an attacker isn't sending a cross-site request to get a token, right? So to complete this and make it secure, what I like to do is I also like to request that the client sends the expired access token in the body of that request. So the expired access token acts as sort of a CSRF token in this function, right? So you can, in the server, you can validate that the client knows what was the access token that just expired, and that also has access to that cookie, right? So you check those 2, and then you return a new access token that lasts for another 15 minutes or 10. If you want to make it even more secure, level 2 will be to also, when you issue, so you're always issuing an access and a refresh token together, right? With this method. So you can request that when you get a call on the refresh endpoint, that the access and the refresh token that you get were issued together, that they're not from different sets. Okay, because imagine that you can have the same user logged in on multiple browser windows, right? So they're going to have different sets of access and refresh tokens on each, right? So you can make sure that when you issue an access and a refresh token, that they come together. If you get an access token from one set and a refresh token for another set, that's not really, you're not going to accept that. That's too suspicious. So if you use random strings as tokens, not JWTs. If you use random strings, you store the pair in a database. Yes, that's how you do it, plus the expiration dates for both. If you use JWTs, one thing that you can do is when you generate the tokens, you can add a little randomly generated number or string on both the access and the refresh tokens. So you put it in the claims section in addition to the user ID, and then when you receive them back, you can make sure that they both have the same identifier that basically ties an access token to its own, to the corresponding refresh token. This idea of matching the access token to the refresh token that was created at the same time will prevent an attacker that's able to maybe capture an old expired access token, and then somehow is able to send a cross origin request with the cookie, right? So this will prevent that, and as I said, we're talking not we're really trying to to find all the most obscure ways in which you could be attacked, right? But given that this isn't very complicated to do, right? It's not that hard. So I like to do it. I do it, right? It might be a little paranoid, but right. So if we are going to talk about different tabs, then right, you have to decide what kind of sharing you would like to have between the tabs. It's going to get tricky if you're okay with sharing credentials between the tabs, and we're talking tabs in the same browser, right? If this is different browsers, this isn't a problem. But if you're okay with sharing credentials, that's the easiest. You do what we just discussed, right? And that's it. The access token is going to be in local storage. Both tabs will get it. The cookie will also be accessible to both tabs, so that will be okay. You will not be able to do right. So it's going to be the same session. You will not be able to do what I just discussed about not allowing more than one refresh per refresh token. Actually, you might be able to pull it off now that I think about it, because you will be replacing the refresh token. Yeah, maybe it will work. So that's one option. If you want independence, complete independence between, like for example, let's say you want to log in as different users on the two tabs. That complicates things in a big way, right? If you want to have two users on the same browser in different tabs, right? You can do it. In that case, that might be the only one case where using session storage makes sense, because session storage is per tab, and unlike local storage. So in that case, you might be able to figure something out by storing the token in session storage instead of local storage. Session storage will also allow you to do refresh. It will survive, the token will survive a refresh, but it will not survive closing the browser or the tab, right? So you will not be able to do like a remember me type solution using session storage, but every other thing will work. So the one other side of things that you might be vulnerable is in database requests, right? If you make database queries, right? If you make a query, right, and part of that query comes from something that the user provided, then definitely you're at risk. But if you do things the right way, right? If you use any modern ORM or not even ORM, right? If you use the correct way to build your query, which is not concatenating strings yourself, right? If you use placeholders for the parts of the query that are variable, right, instead of concatenating strings yourself, then you're fine, right? Because the framework, be it SQL Alchemy or anything else, as long as you use placeholders or parameters, however they call them, right, then you're fine, right? Because the escaping will happen when the arguments are incorporated by the framework into the query, right? The risk is when you concatenate your arguments yourself. So you should not do that. So the approach, I don't have a very sophisticated approach. My approach is to use a log. So I log operations. For example, a good thing to do is to log all your database queries. In addition to, you are going to have a log for your web server as well, right? So you know all the requests, right, that were hit in your server. You know that. In addition, you should log your queries. You can use that to see what queries are slow, which is not a security thing, but more of a performance side. So if queries are very slow, you can find them in the log. And then address the problem, and then you can also see what people are using, the database for. If someone tries to do SQL injection, you will see it in the query, right? Even with the when you do it properly, you will see the attempt in the SQL that you log, right? So you can use that to find who's trying to play games with your service as well.